Okay. So if you were absent today, we're gonna do a few problems. This is what you missed. This is what we did in class. But the first thing you need to do is get your journal. So if you don't have your journal, go get your journal. So pause the video and go get that journal or a piece of paper if for some reason your journal is not there. All right. Okay, so I assume that you have your journal now. So what we're going to do is we're going to kind of try out some problems that almost like a review, because the test is going to be pretty soon. I think it's next. For some people, it'll be Friday. For some people, it will be Monday. So I just wanted to do some problems here to help us prepare for the test. This is what you missed today, and I had asked that you do these with me in your journal to get ready for that big test. All right, so 8/15 divided by 4/5. The first thing we're going to do is write the problem down. Okay? Same steps for all of these, pretty much. Whenever you divide fractions, we're always going to write the problem first as dividing two fractions. So we're going to keep, change, flip. Keep that 8/15, change that division to multiplication. We're going to flip that fraction to 5/4. Okay, now we're going to check to see if we can, in fact, simplify this. And it appears that we can. So I'm going to cross off. I'm going to divide 15 and 5 both by 5. 15 divided by 5 is 5. 5 divided by 5 is 1. Well, if I look diagonally here, 8 and 4, I can divide those both by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. Now when we multiply, our answer is going to be simplified already. 2 times 1 is 2. 5 times 1 is 5, and that's it. That's all you can do with that. 2/5. Nice. All right. Now this one's a little different because you have a whole number. So that just means like when you rewrite it, you need to write the whole number as a fraction. Because when we do keep, change, flip, we have to have two fractions. So we're going to write that as 10/11 divided by 8/1. Again, if you want to try this on your own and see what you get. Any of these really, because these are all, there's nothing really new here, but it's good to practice because this unit was kind of in the middle of of our remote session, and there's been a lot of changes, so it's not a bad idea to review all this stuff before we take the test. So we're going to keep, change, flip. We're looking diagonally. 11 and 1, nothing. 10 and 8, oh, we can divide those both by 2. 10 divided by 2 is 5. 8 divided by 2 is 4. And now we can multiply. 5 times 1 is 5. 4 times 11, 44. Nice. There's our answer. This next one's kind of similar because it has a whole number. And so, again, the first step is going to be to write it as a whole number over 1 divided by the fraction. So we are going to keep, change, flip. We're going to keep that first fraction, change the division, flip to the reciprocal. Okay, well, 1 and 9, you can't simplify. 8 and 6, however, you can divide those both by 2. 6 divided by 2 is 3. 8 divided by 2 would be 4. Let's see what we get when we multiply. This one might be a little tricky. Let's see, 27/4. Now, I might have to write my answer below here, but 4 goes into 27 how many times? It'd be, I believe, 6 times, right? Because 6 times 4 is 24. So it goes in there 6 times completely. 6 times 4 is 24. You would need 3 more to get to 27, which is why the fraction would be 3, and we're going to keep the denominator 4. We can check it by doing the swoop. 6 times 4 is 24 plus 3 is 27. 27, or 6 3/4 would be the answer. Okie dokie. All right, let's try some more. Let's see how this goes here. Again, if there's any point where I'm going too fast, you can always pause it. Okay. All right, now here we have a mixed number. We have to do keep, change, flip. We need two fractions. So we need to change this to a fraction, an improper fraction. So we're going to do the swoop for 4 2/3. We're going to multiply and then add. 3 times 4 is 12, plus 2 is 14/3. Now this other fraction is already a fraction, so we don't have to do anything with that. So we're first going to write it as a division of problem with two fractions. That's always the first step. Then we're going to keep, change, flip. Excuse me, we're going to keep that first fraction, change the division to multiplication. We're going to flip that fraction. Next, we'll look to see if we can simplify. I believe we can. If you look at 3 and 24, you can divide those both by 3. You can divide those both by 3. 3 divided by 3 is 1. 24 divided by 3 is 8. But if you look at this diagonal too, you can actually simplify those as well. 14 and 21, what can you divide them both by? Well, you can divide them both by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. So always look at both diagonals because there might be a chance to simplify both. 2 times 8 is 16. 1 times 3 is 3. 3 goes into 16. It would be 5 times, because 5 times 3 is 15. To get to 16, you would need one more, and we're going to keep the denominator. So it would be 5 1/3. To check that, 3 times 5 is 15, plus 1 is 16, 16/3. The answer would be 5 1/3. Okie dokie. This next one here, 10 1/2 divided by 2 4/7. Do a little swoop. Another swoop, because we have to change these both to fractions. Multiply, add. Multiply, add. Whoop. Screen change size for a moment. All right, so we'll change these both to fractions. We can't do this now. We can't divide this as the numbers are now. 2 times 10 is 20, plus 1 is 21 halves. Excuse me. Divided by, keeping the division, 7 times 2 is 14, plus 4 is 18 sevenths. All right. Now that we have division with fractions, we have two fractions, we can keep, change, flip. First fraction is 21 halves. Change that to multiplication, and that's going to be 7/18. Now this one's a little tricky to simplify. You can simplify it. 2 and 7, you can't do anything with that. 21 and 18, though, you can divide those both by 3. 3. So we'll divide them both by 3. 21 divided by 3 is 7. 18 divided by 3 is 6. All right, now we multiply. This one's a little tricky. It's worth it, though. 7 times 7 is 49. 2 times 6 is 12. Well, how many times does 12 go into 49? 12 times 4 is 48. So that's as much as it can go in there. Go in there 4 times. 12 times 4 will get to 48. You need one, excuse me, you need one more to get to 49. So it'd be 4 and 1/12. Nice, 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 nice. All right. Here we go. Let's try this one here. 1 4/5. Got to change that to a fraction there. Do a little swoop, times and add. 5 times 1 is 5, plus 4 is 9/5. And then we have to write 18 as a fraction. 18 over 1, or 18 wholes. Once we have them both as fractions, we can divide. Or actually, we can keep, change, flip. I take that back. Keeping the first one. Changing the division to multiplication. And then we're going to flip that fraction. Can we simplify? Can we simplify? I believe we can. I believe we can. The 9 and the 18. Okay, we can divide them both by 9. 9 divided by 9 is 1. 18 divided by 9 is 2. And so what happens is you get 1 times 1 is 1, 5 times 2 is 10. 1/10. What a problem. What a problem. All right. So now we're going to try some word problems. And what's key about setting up word problems is to think about like what number goes first. Because with division, you got to make sure to put the right number first or else you get the wrong answer. So this one says, how many 1/3 pound burgers can be made with 2.5 pounds of ground beef? Now, what I usually think when I do, when I set up a division problem, the total, whatever the total amount is going to go first. Usually. That's not always the case with, we'll see one today where it's like, you don't know what the total is necessarily, but when you set up a division problem, most of the time the total goes first. So we're thinking like, what's the total amount of ground beef she has, or he, or whoever this is? They have 2.5 pounds. They want to make 1/3 pound burgers. This is the total right here. The 2.5 goes first, but I'm going to write 2.5 as a improper fraction. 2 times 2 is 4, plus 1 is 5. So the total would be 5 halves. Something caught in my throat. I apologize that I keep stammering here. We're going to divide that by 1/3. 1/3 is the size of the groups. So the total is 5 halves. We're going to divide it into 1/3 pieces. So we're going to keep, change, we're going to flip it. Keep the first one. Multiply 3 over 1. Whoop. 5 times 3, 15. 2 times 1, believe it or not, is 2. Now we can't leave it like that. How many times does 2 go into 15? 2 goes into 15 7 times. 2 times 7 is 14. You need 1 more to get to 15. This would be 7.5. Now, here's the thing. How many of these 1 pound burgers can you make? Yeah, I wouldn't probably take points off if you put this 7.5, but the real answer is it's really 7. You can make 7 of these burgers because the other piece is not a 1/3 pound burger. So it depends on the problem, whether you keep the fraction, whether you don't. But for this one, I would take either. But in real life, it's really, you can only make 7 full burgers. The other one would be maybe a slider, perhaps. All right, this one's a little different. A basketball is 5'6" feet wide. A baseball is 3'11" feet wide. How many times wider is a basketball than a baseball? So with a problem like this, again, we're comparing two things, basketball to baseball. That means the basketball number goes first and then the baseball number. So the first number is going to be the basketball because we're comparing basketball. It was the other way around. We'd flip the numbers, but the problem says basketball and then baseball. That's how we're going to set that one up. The basketball is definitely wider, so we should get a number that is greater than 1. We'll see. We'll see what it is, though. Keep, change, flip. We get 5, 6. Change the division to multiplication. Flip that fraction. I don't think we can simplify here. No, we cannot. So we multiply. 5 and 3, nothing. You can't do anything with that. 6 and 11, nothing either. 5 times 11 would be 55. 6 times 3 is 18. All right, so how many times would 18 go into 55? Let's do a little workout to the side here. Maybe 3? 8 times 3 is 24. 3 times 1 is, it's a good guess. Good guess by me. All right, so 18 goes into 55 3 times. You get to 54. You need 1 more to get to 55, so it'd be 3 and 1/18 times wider. So basketball is a little bit more than 3 times wider than a baseball. That's good to know. All right, this is a different type of problem here. It says a clothing store has 16 hats, 12 scarves, and 28 shirts. An employee is making a display with these items. Each row has to have an equal number of hats, scarves, and shirts. What is the greatest number? Greatest number in each row? I'll tell you what, it's either GCF or LCM. This is not a fraction problem. It's either GCF or LCM. Because the word greatest is in there, that's GCF. We're going to find the greatest number of articles of clothing in each row. So we're going to write these numbers down, 16, 12, 28, and we're going to break them down. Again, you can go off and try this one on your own and see what you get. if you want to go ahead of me a little bit. 16 would be 4 times 4. And then you can break each 4 down into 2s. Circle the 2s. Same thing with this 4. 2 times 2. Circle it. Circle it. 12, maybe like, I don't know, 6 times 2 or something like that. Circle the 2, break the 6 down into 3 times 2. Again, this is GCF, the greatest number per row. That's a clue that it's GCF. 28, I'm going to do 7 times 4. Circle the 7. All right, let's see what they have in common. All 3 of them have to share the same number. Let's see. They all have a 2. So I'm going to cross out a 2. They all have a 2. Let's see, what else do they have? Oh, they all have another 2. I believe that's it. Yeah, those are the only numbers they have in common. 2 times 2 would be 4. All right. So the answer would be 4. The GCF is 4. It would be 4 articles per row. It's nice. Nice to know. So it'd be 4 rows of hats, 3 rows of scarves, 7 rows of shirts. Okay. We're going to try 3 more problems, and we'll be all set. We'll be all set here. So Vicky goes to Tops every 32 days. Harris goes to Tops every 12. If they were both there today, in how many days will they be back at Tops together again? When is this going to happen again? This is not a fraction problem, of course. This is least common multiple. When is something going to happen again? That's least common multiple. We're going to make a list. This is complete opposite of GCF. We're going to make a list here to find least common multiple. That's the key word. When's it going to happen again? So we're going to count by, I'm going to count by 32s first, actually. I said 12. 32 would be the first one. Pardon. And then 64. And then 96. I'm going to stop there. It might not be one of these, but I'm going to stop there for now. So we got 12, 24, 36, nothing yet. 48. 60 would be the next one. 72. I'm going to kind of go into the next box here. Apologize to the next box. Sorry. And then the next one would be 97. Ooh, look at that. So with least common multiple, you count both numbers until you find the same amount. In this case, it'd be 96. You just got to be careful counting. This is where people would make a mistake. That's 60. Some people would put 50, but it would actually be 10 more than that. It would be 60. So you got to just make sure, watch out when you count, that you're counting accurately. All right. Kelsey and her 4 friends are making scarves. Nice. They had 4 1/3 yards of fabric to share equally. How many yards of fabric did each person get? Okay, so we're dividing the fabric for each person. So the fabric would go first. Fabric per person. Fabric, person. That's what it says. Fabric, each person get. So we're going to start with that 4 1/3, but we're going to change it to a fraction first. 3 times 4 is 12, plus 1 is going to be 13/3 yards of fabric, divided by, now, the big question is it 4 or 5? Are we divided by 4 or 5? Kelsey had 4 friends, but it seems to me by the question that Kelsey is also making a scarf. So there are 5 people. We'd have to write that as a fraction over 1, though, of course. So this is how much fabric they have. This is how many people. We're going to keep change flips, see how many times, or see how much of the fabric each person's going to get. 13/3 times 1/5. I don't think you can do anything here. 13 and 5, certainly not. 1 and 3, certainly not. 1 times 13 is 13. 5 times 3 is 15. And that's going to be yards of fabric. All right. Last one. A hedgehog named Demetrius, great name, is 7/12 years old A rabbit named Pocket, another amazing name, 2 3/9 years old. How many times older is Pocket than Demetrius? So that's the order we're going to put them in. Even though Demetrius is first in the problem, it says how many times older is Pocket. The question is what we're paying attention to. Pocket goes first, then our dear friend Demetrius. So Pocket is 2 3/9. Well, I'm going to change that to a fraction. That's going to be, what, 18. 2 times 9 is 18, plus 3 is 21/9. Divided by Demetrius, who is 7/12. Way to go, Demetrius. All right. We're going to keep, change, flip, of course. Notice we set all these problems up the same exact way. I hope you did too. Keep, change, flip. Can we simplify? I believe we can. I believe we can. Look at 9 and 12. What can you divide 9 and 12 by? 3. 9 divided by 3 is 3. 12 divided by 3 is 4. Okay. 21 and 7. What can you divide these by? Well, it should be 7. 21 divided by 7 is 3. 7 divided by 7 is 1. 3 times 4 is 12. 3 times 1 is 3. 12 divided by 3 is 4. Pocket is 4 times older. Good old Pocket. Whoop, didn't mean to put a period there. All right, so that was just some practice. Sort of review some of the ideas that we were been working with this unit. If you have any questions while you're working, please let me know. If not, then I hope you have a great day, and I hope you're doing well. All right, bye-bye.